Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to take the concurrence as well as the feedback from you guys, the quality of video as well as audio. Is it perfect or not? If it is perfect, just write perfect over the live chat. Anyways, the agenda behind today's video to smash the complete concept of the time response analysis of the second order system. Although in last class I was briefly discussing about the concept of second order system, but I could not finish this topic in last class. But the agenda behind today's video is very precise and clear. We are going to complete the concept of time response analysis of the second order system completely. Agreed what I am saying? And once this part is over, probably the next video, which is supposed to come tomorrow at 2 p.m, we would be discussing about the concept of root locus, which is a very important concept, and I have seen most of the students used to get stuck over the good design problem related to the root locus. So each one of us would mark the topic which we are going to cover in today's lecture is going to be the time response analysis of the second order system, and definitely we are going to finish this topic in today's video itself. If you guys would be able to recall what I was studying in last probably 30 minutes, let me write those down. I was discussing about the locations of the pole of the standard second order system. How do we locate the poles? First, what we do, we used to have a transfer function. The transfer functions would have denominators polynomial. If the denominators polynomial got compared with 0, you would get its characteristic equation, and the roots of the characteristic equation is nothing but the locations of the pole. So if you guys would be able to recall, what was the standard second order transfer function? It was T of S was equals to k times of omega n square, k times of omega n square divided by of s square plus of 2 zeta omega ns plus of omega n square. And as I am interested in finding the locations of the standard second order system, what I would do, let me copy this down. I would compare the denominators polynomial with 0, and which would be a quadratic equation, and the roots of this quadratic equations are nothing but the locations of the second order poles. How many number of poles you'll have? The 2 number of poles you'll have. Why the 2 number of poles you'll have? See, it is a quadratic equation, and hence the number of roots, which would be number of poles, would be precisely 2. So may I know what they would be? So let me write the third important point. The roots can be easily calculated with the help of quadratic equation S1 and S2. What it used to be? It used to be minus of b. What is the minus b? In place of b, the 2 zeta omega n is there. So it would become minus 2 zeta omega n plus minus b square plus minus b square. B square is nothing but the square of 2 zeta omega n, which would become 4 zeta omega n square minus of 4 ac. May I know what is the a over there? The a is 1 and c is omega n square. So here it becomes 4 times of omega n square divided by of 2. And anyways, we derived this formula even in the last class. So let me write straight away what was the conclusion. The conclusion was S1 S2 was equals to of minus zeta omega n plus minus the iota was taken out, and here it became omega n within the bracket root over of 1 minus of zeta square. You can put within a block. This was an important outcome. And you can see very well, now your roots are supposed to be a complex conjugate. If the value of, see, try to understand what I am saying. The values are supposed to be complex conjugate if this worth or 1 minus zeta square is a positive value. What does that mean of it? That means the zeta is in between minus 1 to plus 1. So I have assumed the zeta is in between minus 1 to 1. In that case, the root over factor or the component within the root over is a positive value. That means it is gonna be a real value. The real value is getting multiplied with a iota. That means it would always be a imaginary part, and this would always be a real part, provided 1 minus of zeta square should not become a negative value. If 1 minus zeta square becomes a negative value, again it would create a iota and iota would get multiplied. It would become a real part. The real part and real part completely, the roots or the poles would be located over the real axis. So what I have assumed so far, I have assumed the value of zeta has been chosen in such a way that the value of 1 minus zeta square is always a positive value, or at worst it's 0. What does that mean of it? That means it will not create iota, and if it not creates iota, definitely this iota would remain as it is. Put together, this becomes a real part and this becomes an imaginary part. Till this point, each and everything must be clear to all of us. So in future, what I would be doing, I would be assuming minus zeta omega n is the real part. Let's take it's a x, and similarly omega n root over of 1 minus zeta square with the plus minus sign as the imaginary part, which is y. Probably you could figure it out or not, but yes, this relationship or this outcome of the locations of the second order system follows a strict relationship of a circle. May I know what used to be the equation of the circle? The equation of the circle used to be x square plus of y square is equals to of a square. May I know what does it mean of it? That means it's the equation of a circle whose center is at origin, and at the same time the radius is nothing but a. And even if you'll take minus zeta omega n as x, and similarly plus minus omega n root over of 1 minus zeta square as y, you will get to know it becomes minus zeta omega n to the power of 2, and here it becomes plus minus of omega n root over of 1 minus of zeta square. 1 minus of zeta square to the power of 2. Once you will calculate this, the result is simply going to be omega n square, which we have seen in the last class. What does that mean of it? That means although the zeta might be changing its values, what I am saying, although the zeta might be changing its values, like the zeta could be 0, where is the case of undamped. Similarly, the zeta could be 0.1, 0.2, where the value is becoming more and more damped, and even the zeta becomes 1, then also the square of the x component and the square of the y component is always a constant quantity. What does it mean of it? That means if the zeta is changing, definitely the locations of the poles are supposed to change, but if the locations of the poles are changing, still they would make a certain trajectory, they would make a certain path that would always make a circle whose center is centered at origin at S plane, and similarly it is making the distance of omega n from the origin. Did you agree what I am saying? In future we are going to change the value of zeta, no? If the zeta is changing, what I am saying, definitely if zeta would change, the value of the real part would change, the value of the imaginary part would change, but together the distance from the origin of the S plane would not change. So one of the very important outcome we are going to write, what it is, poles would always be located, poles, how many poles we have? 2. Poles would always be located, will always be located omega n distance away, from origin. And this statement is true only and only. See. When this statement is true, that is true only and only if this is an imaginary component and this is a real component. This would be an imaginary component only and only if this part is real, which is getting multiplied with the iota component. If 1 minus of zeta square becomes a negative value, they themselves would create an iota component, and the iota and iota would become multiplied, and together it would have only and only real component. That means what I am saying, as the value of zeta is changing, in circle the poles are supposed to change its location, but it would always maintain the distance from the origin as omega. May I know when it would be true? It would be true only and only when the zeta is in between minus 1 till plus 1, including minus 1 and plus 1. Why? Because if you go lower than the minus 1 value, what will become? 1 minus of zeta square would become a negative value, and again it would become a completely real component. And similarly, if zeta goes beyond 1, what will happen? This would again become a negative component, which would lead iota, and the iota and iota is getting multiplied. Again it would become a complete real component. Till this point, nobody should have any doubt as such. Now what I am going to do over here, see, Let me draw a table. Let me draw a table. I'm going to draw a table over here. See, what I am going to do, I am going to change the values of zeta from 0 slowly towards 0.1, 0.2, 0.3, and I would go till 1, and I would like to try to understand how the real part of your second order pole and similarly the imaginary part of your second order pole is getting changed. So what I am going to do over here, I am going to take the variations in zeta, and I would see what is the real part of it. That means I would be watching over the real part of the pole, and similarly I would be watching about the imaginary part of the pole. Yes, at very beginning, let's start with 0. Once I am keeping zeta is equals to 0, you can see very well, once the zeta has been fed as 0, the 0 would get multiplied with omega n. Definitely the real component is gonna be 0. And once I feed zeta is equals to 0, you would be getting the imaginary component is gonna be how much? Omega n. Agreed? Now what I am going to do, slowly I am going to increase the value of zeta. From zeta is equals to 0, let's go to the zeta is equals to 0.5. And once we take zeta is equals to 0.5, you can see very well the value of x have become minus 0.5 times of omega n. Yes, that means the real part got shifted towards the left hand side of the S-plane. Initially it was 0, now it became minus 0.5 times of omega n. And as the omega n is always positive, minus 0.5 times of omega n would always be negative. So you can say it is a negative real part. Agreed? Similarly, let me go ahead with this. So what I am going to do over here, I had the calculator. Anyways, you guys had to calculate how much you would be getting over here. So here it becomes omega n root over 1 minus zeta square would become 0.25. And as the value of zeta is increasing, maybe at 0.9, see what is happening? The real part is getting shifted more and more towards the left hand side. Yes. And you can see very well the imaginary part is getting compressed. I am not going into the detailed value analysis of the imaginary as well as real part. Okay. Agreed what I am saying? So may I know what's the conclusion we got out of this? Let me recall what we were studying. Basically, I was discussing about the locations of the pole of the standard second order system. So what I did, first I took the characteristic equation of the standard second order system, which is nothing but the denominators of the transfer function has to get compared with 0. Yes. Now we got to know about its roots. Roots was minus zeta omega n plus minus j omega n root over 1 minus of zeta square. See, although this would be a real part and this would be an imaginary part, provided 1 minus zeta square is a positive value, whereas zeta has to be in between minus 1 to plus 1. Yes. So I have taken a situation where the zeta is only in between minus 1 to 1, including minus 1 and 1. That means it would always be an imaginary part and it would always be a real part of your second order poles. But we got to know it's your real part, you can say it's a component of x, it's the imaginary part, you can say it's a component of y. And once you recall the equation of circle, you got to know the x square plus y square is equals to a square. And if I would feed instead the x as minus zeta omega n and similarly instead the y omega n root over of 1 minus zeta square, we got to know the result is simply omega n square. What does that mean of it? That means in future if you are changing the value of zeta, obviously in between minus 1 to plus 1, including minus 1 and plus 1, what will happen? Your root would always be making a distance which is equals to of omega n from the origin. Put together, if you are changing the value of zeta from minus 1 to plus 1, what will happen? The zeta would make a complete circle. Till this point, nobody should have any doubt as such. But now one thing comes in your mind. Although sir, zeta have got the range from minus 1 to plus 1, but why you are taking only positive value of zeta? See, if the zeta becomes negative, the system would become an unstable system. If zeta becomes negative, the system would become an unstable system. Why? If the zeta becomes negative, once you will draw its characteristic equation, and from row through it, if you will see the number of sign changes, there would be one sign change. That is what I am saying. I am just going to analyze for the positive values of zeta, and that is why I left the reason where the zeta was from -1 to 0. I started from 0 and I went till 1. And end of the day, if I would take the value of zeta as 1, agreed? In that case, what is happening over here? You can see very well. Here it becomes minus of omega n, and this becomes 0. Or you can say now the poles are pure real. Agreed? So this is what your real part, and this is what your imaginary part. Yes. So what I am going to do over here, let me take the next slide, and whatever the mathematical conclusions we have got it so far, we are going to draw in a form of a circle. So what I am going to do at very beginning. So let me take a y-axis. This is what my y-axis, and this is what my x-axis. And this plane is nothing but the s-plane. So the real axis of the s-plane is the sigma axis, and similarly the imaginary axis of the s-plane is the j omega axis. And the plane at which the analysis or the location of the second order poles are to be represented is nothing but the s-plane. And you have seen earlier, if the value of zetas are supposed to change, the pole's location would change from its place, but they would always be making a round and round and round, whose origin or whose center would be origin of the s-plane. At the same time, the distance would be the distance of omega n. So what I am going to do, let me take a circle. So here I have taken a circle. Just a minute. Sort of this. Probably it may not be looking exactly circle, but it is circle. And you can see very well the circle is centered around the origin of the s-plane. That means the value of sigma would become 0 and the value of omega would become 0 at this place. Not only that, even we have seen the radial distance of this circle would be precisely equals to of omega n. So what does it mean of it? That means this distance is simply going to be omega n. Agreed? Till this point nobody should have any doubt as such. If you want to locate what would be the exactly location of this point, may I know what would be the worth of abscissa? See, this point is kept over the real axis. That means the value of imaginary component would become 0, and the distance from the origin is simply going to be omega n, and that too towards the right hand side of the x-axis. By default it would become omega n comma of 0, or simply you can write this as omega n. Similarly, towards the left hand side you can write the location is minus of omega n. Similarly, at up side you can write the location as c. The real component over the y-axis would become 0. So simply it is going to be a real component is simply going to be 0. And may I know what's going to be the imaginary component? The imaginary component, how much distance is there from the origin? It's a omega n, and hence it's going to be 0 plus of j omega n. And here it becomes 0 minus of j omega n. And if you want to write, this can be written as j0, and similarly this can be written as j0. Agreed till this point? Nobody should have any doubt as such. Agreed? Now what I am going to do, for the different values of zeta, whatever the locations of the second order poles we have located, now we are going to draw over the s-plane. So let me start with zeta is equals to 0. At zeta is equals to 0, may I know where the poles were located? See, the real part was 0, whereas the imaginary part was omega n. That means you have a complex conjugate pole. The one would be at plus j omega n, the another would be at minus j omega n. You can see very well. That means the poles are supposed to be located at plus j omega n and minus j omega n. Let's take it's a pole 1 and it's a pair of complex conjugate 1 dash. Agreed? Till this point nobody should have any doubt as such. But anyways, let me brief about this point more. May I know which point it is? We get the locations of the pole S1 and S2 at plus minus j omega n when the zeta is equals to of 0. May I know which type of pole it is? It is a complex conjugate pole, with zero real part, pole with zero real part, yes. And when I was discussing about the response when the zeta used to be 0, we have seen the response used to be undamped. That means the response would be keep oscillating with the constant magnitude and frequency. So I have seen repeatedly the questions do come from this zone. Once they would be asking, once they would be giving a situation where the zeta is 0, they may ask the location of the poles, and even they may ask the response given by the system. So keep in mind, when the zeta has been fixed to 0, by default the location of the standard second order pole would be pure imaginary, and they would be kept at plus minus j omega n, where the omega n is nothing but natural frequency of oscillation. And at the same time, if I would ask how would be the response of the system, which we have already discussed in the last class, the response of the system is gonna be pure undamped or sustained oscillatory. What does it mean by the sustained? Neither it is increasing, neither it is decreasing, it is just sustaining its magnitude as well as frequency. Agreed? Is that part clear to all of us? Why it has come to the plus minus j omega n? You can see very well. The location was at omega n. You can see very well. Being a complex conjugate pole, one would go towards a plus j omega n, the another would come to the minus j omega n. Nobody should have any doubt as such. Now, if you will keenly observe this table, you will get to know as the value of zeta is increasing, no, see, the real part is going to be more and more and more negative. That means the closed loop poles would shift towards the left hand side. Not only that, even you can see the imaginary part is going to decrease again and again. Initially it was omega n, now it is lesser than omega n. Now even if you will take the next component, it would be even lesser than this. What does it mean of it? That means one pole was kept somewhere here over the imaginary axis, and the another was kept over here over the imaginary axis. Now they would start coming down. So what is happening over here? So the real part of the closed loop pole or real part of the second order poles are shifted towards the left hand side if I take the reference of real axis, and similarly if I take the reference of imaginary axis, they are coming nearer. Agreed what I am saying? I would repeat once again. As the value of zeta is increasing from 0 to 1, you cannot go beyond 1. So the real part of the zeta is keep decreasing or keep going towards the negative side, whereas the imaginary part is keep decreasing or they are coming nearby. But they are doing so such that still they would always be falling over a circle, and you can see very well. If you take one pole over here, maybe at zeta is equals to of 0.2, the another would be just a minute. Let's take their pairs. I may call it 1, here it's 2, here it's a 2 dash. May I know what's the difference has been taken place in compare with the pair 1 1 dash and 2 2 dash? See. In real axis, there was a shifting of the pole towards the left hand side. You can see very well. Here the real part of the complex conjugate pole was 0, whereas the real part of this complex conjugate poles are negative. Yes, not only that, even you can see very well, initially the imaginary part of this complex conjugate pole was omega n, now it is little bit lower, or you can see very well there was shifting of the complex conjugate pole downside and here upside. Agreed what I am saying? And what is happening over here, as the value of zeta is increasing, what will happen? The poles would start shifting its location. They may come to 3 and 3 dash. They may come to 4 dash. Here the value of zeta is increasing. Keep in mind, nobody should have any doubt as such. The value of zeta is increasing. Here the value of zeta was 0. And in between, the value of zeta is in between 0 to 1. Agreed? And now at last, what is happening over here? Now at last, if you keep zeta is equals to 1, you can see very well both of the poles are being found at minus omega n, whereas the component of the imaginary component was simply 0. What does that mean of it? That you can understand in this way that at zeta is equals to 0, both of the poles were kept over the plus j omega n minus j omega n, and as the value of zeta was getting increased, they were coming nearby, but they were following a straight path of a circle having a radius is equals to omega n and centered around the origin of S plane. And as the zeta became precisely 1, both of the pole, this pole as well as this pole, have been found exactly at which point? Minus omega n point. May I know where the poles have been located? The poles have been located at S1, S2, both have been located at minus of omega n. Minus of omega n. May I know what would be the worth of zeta over here? The zeta is simply gonna be 1. May I know which type of system is being called? It's called critically damped system. Critically damped system. Critically damped system. Agreed? Nobody should have any doubt as such. And we have seen when the zeta becomes 1, how used to be the response? The response would be pure exponent. The response would be pure exponent. It's C versus C of t curve. C of t curve. Yes. And if you take the situation somewhere here, maybe at this point, obviously the value of zeta is in between. Zeta is in between 0 to 1. Which type of system it would be? It would be a underdamped system. Underdamped system. Underdamped system. It would be a underdamped system. Yes. May I know how would be the response? The response would be damped oscillatory. That means it would have oscillation, but still it would be damping as the value of t prevails. It's a damped oscillatory. Oscillatory. Now, if you take another scenario at zeta is equals to 0, both were at pure imaginary point, and as the value of zeta was increasing, the real part was getting more and more negative and the imaginary part was getting shrinked. At zeta is equals to 1, they met at minus omega n, and what will happen if the zeta gone beyond 1? What will happen? The one pole would go towards the left hand side over the x-axis and another pole would go towards the right hand side of the x-axis. Why it would happen so? You can see very well. If the zeta is greater than 1, 1 minus of zeta square would become a negative value, and as the negative value is coming under the root over, it would create another iota component. This iota and this iota gets multiplied and would become a real component, and put together you can say the S1 and S2, after adding and after subtracting, both would be pure real poles. That means the one pole would be towards the left hand side, the another pole would be towards the right hand side. See, sort of this. Agreed what I am saying? You can take this as 4 dash, 5 dash, and they would be overdamped in nature. Overdamped. So just I wanted to ask from each one of you, till this point each and everything is clear or not? If any type of doubts you guys are having still over this omega n circle, you can ask over the live chat, and thereafter I will straight away move into the important table from where the problems used to come repeatedly. So till this point each and everything is clear or not? At zeta is equals to 0, your poles were pure imaginary. They were kept over the plus j omega n and minus j omega n. As the value of zeta got increased, they have been following a path of circle. What does that mean of it? That means its real part is getting more and more negative, and similarly its imaginary part is getting shrunk. And similarly at zeta is equals to 1, they would be met at minus omega n, or you can say their poles are pure real as well as repetitive. And as the value of zeta would go beyond 1, what will happen? The one pole would go towards the right hand side, the another pole would go towards the left hand side, and put together the nature of the poles would be pure real and distinct. Sir, the pole moves away from the origin. Can we say that the stability? No, stability, nothing to be told about the stability. I would come in each and everything once the time permits. You need not to relate anything with the stability. Now you can see very well, when the value of zeta was 1, the nature of the poles were pure real, pure real and repeating and repeating. And you can see very well when we went into the overdamped system, you can see very well the poles were pure real, but they were distinct. Agreed? So till this point nobody should have any doubt as such. Agreed? So let me draw a important table, and within that table probably whatever the concepts we have studied so far would be encapsulated. So let me take a table. Just a minute. Each one of us should mark this table properly in your copy. The first data is the serial number, or the second column is being dedicated to the value of zeta. The third column is being dedicated towards the type of system. The next column is dedicated to the nature of the poles. And the last column is being dedicated to the remarks. Yes. So let me start with the first one. For that also, let me take few number of more rows. Yes. So at very beginning I would start with taking the value of zeta is equals to 0. Oh sorry, it is a serial number. At very beginning I would start taking the value of zeta is equals to 0. Tell me which type of system it is. When I was taken the value of zeta is equals to 0, which type of system it is. I am not talking about the type of the system. This system would categorize under which kind of the system. Would it be underdamped? Would it be a overdamped? Would it be a critically damped? Which type of system it is. We have seen when the zeta becomes 0, there is no damping which has been forcing to oscillation to be damped down. That means which type of system it is? It is the undamped system. It is undamped system. Nobody should have any doubt as such. So whatever the data we have concluded so far, I am going to list down within a same table, and probably end of the day once you have a clear cut idea about this table and the data from where those data have come into this table, you would be more than comfortable at least on the concept of second order system. May I know what would be the nature of the pole? See, we have seen when we took the value of zeta is equals to 0, the poles were pure imaginary. That means it does not contain any of its real part. So if we talk about the nature of pole, definitely it's gonna be pure imaginary. And if exactly you want to locate where they would be located, so they would be exactly located at plus minus of j omega n. Yes, and if we talk about its remarks, in remarks basically we are concerned about its response. If a system which has the zeta is equals to 0, which type of response this system is going to reveal. So tell me what type of response you will be having. You would be having a sustained oscillation at the output side. So here it's gonna be sustained oscillatory response. Oscillatory response. What does it mean by the sustained oscillatory response, which we have already communicated? Response with the constant magnitude as well as frequency. As the time goes on, the magnitude would not be increased, not be decreased, and similarly, neither the time period would increase nor decrease. That means the frequency as well as the magnitude is going to be constant. Yes, it's going to be sustained oscillatory response. Nobody should have any doubt as such over this. Or you can write with constant frequency, and magnitude. Till this point, each and everything must be clear to all of us. Yes. Now, let me take the second scenario. Now, the scenario has been taken in such a way that the zeta has been taken in between 0 to 1, neither 0 nor 1. Neither 0 nor 1. Which type of system it is? Which we have already seen. See, if zeta was 0, both of the poles were complex conjugate pole kept over the imaginary axis. As the value of zeta got increased, what is happening over here? They have been following the path of circle and they have been coming nearby, and once the zeta becomes precisely 1, both of the poles were kept over the real axis at the same point minus of omega n. But I am excluding 1 as well as 0. That means I am excluding this part as well as this part. So may I know how the poles have been located? See, either you take this portion, either you take this location. You can see very well, this pole have got its real part as well as imaginary part. May I know the real part is positive or negative? Obviously the real part is negative. What about the imaginary part? Yes, it has a imaginary part also. So easily you can say it would be a complex conjugate pole. Why? Because for 2 you would have 2 dash, for 3 you would have 3 dash. So you would have a complex conjugate poles having the negative real part, So you can see very well, when the zeta is in between 0 to 1, the nature of the poles are gonna be complex conjugate, having negative real part. Yes. Which type of system it is being categorized? It is nothing but under-damped system. That means it's the system which is under the supervision of damping. That means as the oscillation would take place, the system would have an inherent property that it would start compressing that oscillation, and end of the day it would attain its steady state value. Yes. May I know what would be the remark? It would be damped oscillatory. If you want to draw how it would look like, so it would be sort of this. Agreed? Now what I am going to do over here, let's take the third case. Let me change the color first. Let me take the third case where the zeta was precisely taken to be 1. And if you go back into the last slide, you will get to know when the zeta was precisely 1, both of the poles were pure real and negative. Why negative? Because they have been lying over the minus of omega n. So you can see very well, when the zeta was 1, we have seen earlier, it's a type of critically damped system. And if we talk about the nature of pole, it would be pure real and repeating. And if we'll talk where they would be repeated, it would be minus omega n. Yes, for the better clarity, when you can write pure real, negative and repeating. Why? Because they have been falling towards the left hand side of the x-axis. And anyways, if we talk about its output, it would be pure exponent. So if we talk about its response, the response would not oscillate. It would keep increasing time to time and would get settled to the steady state value. Yes. Now if I take the fourth condition, where the zeta has been taken greater than 1. Zeta has been taken greater than 1. Now, which type of system it is? We have seen in last class, this system is being categorized under the overdamped system. Overdamped system. And if we talk about the nature of the pole, easily you can see the nature of the pole. One pole goes towards the right hand side, taking the reference of minus omega, and the another goes towards the left hand side. What does that mean of it? Both of the poles have been kept over the real axis. That's the first thing. Both have only and only real part. That is second thing. And both of them are negative. So you can say poles are purely real, negative, and now here rather repeating, they are distinct. Pure, real, negative, and they are distinct. The values are supposed to be different, distinct. Yes. Till this point, nobody should have any doubt as such. And here, if we talk about the output would be more and more sluggish. That means it would take more time to reach its steady state value. To reach its steady state value. Till this point, nobody should have any doubt as such. And I would like to ask one thing. Remarks. In remarks, I wanted to mark the output for the different kinds of the system. May I know? See, if you are observing the output, there must be a certain input now. So may I know, this responses are the response for which kind of input? The kind of the input is a unit step input, or for the time being, you can just write step input. Step input. Step input. That means when the standard second order system got excited by the step input, in those cases, these are the outputs. These are the outputs. Yes, till this point, nobody should have any doubt as such. So I would like to ask from each one of you, at least this table is clear to all of us. If it is just clear, you write clear over the live chat, so at least I'll get to know that each and everything is properly communicated from my side. And then we would take few number of well-designed problem. Although those problems have not been appeared on the gate examination, but still we would take few number of, for few varieties number of the problem. So you guys would have a better understanding related to the concepts of the second order system and the locations of their poles. And the locations of their poles. Agreed? Crystal clear, sir. Thank you, dear. Okay. Yes. So now let me take few number of systems. And I would like to ask from each one of you, that system would be categorized under the overdamped system, underdamped system, critically damped system. You had to just mark the question out. Let me take the few number of questions. Yes. Let's take the first question. The transfer function of the first system is somewhere being taken as, let's take, is a 4 s square plus of 4s plus of 4 plus of 4. Tell me which type of system it is, whether it's underdamped system, overdamped system, critically damped system. Tell me which type of system it is. It's your first question. Now let me take the second question. If T of S is equals to, let's take 2 divided by of s square 2s plus of 4. Again, I would like to ask the same question. Which type of system it is, whether it is underdamped, overdamped, critically damped. Yes. Third question. Two divided by of s square plus of 2s minus of 4. Now this is going to be your third problem. I would like to ask the same question, which kind of system it is. Fourth. Let me take the fourth question. So now this 4 number of question goes to you guys, and you had to just figure it out which kind of system they are, the first system, second system, third system and the fourth system. So the answer have started coming. Anyways, the first, second, third and fourth. See, anyways, whenever you come across this situation, by watching the transfer function, if you had to calculate the value of zeta, what would be your approach? What would be your approach? See, this factor, the multiplier factor of S used to be 2 times of zeta into omega n, and the zeta is the factor which would decide which type of system it is. So until and unless the value of zeta is not known, you would not be able to classify the system under the overdamped, underdamped or critically damped. So what would be your first approach? Your first approach is to get the value of zeta. But anyways, how we would get the value of zeta, because along with S, the 2 zeta and omega n is also coming. So first you have to calculate the value of omega n. See, whenever you are dealing with any sort of problem where we need to classify the system over the underdamped, critically damped or overdamped, you had to get the value of omega n first. Now I have seen many of the times what the student do mistakes. See, what they assume, the numerator is omega n square. No, my dear friend, the numerator is not omega n square itself, it is k times of omega n square. So nobody by taking a square root of the numerator should get the value of omega n. Omega n should always be calculated by this term. Agreed what I am saying? I have seen in many times the student do mistakes. What they would do, they would take a square root of the numerator, they would find the value of omega n, and using that omega n they would get the value of zeta, sometime which used to be wrong. At least in this problem, omega n square at denominator and k times of omega n square at numerator, both of them are matching, and hence if you calculate the value of omega n from the numerator itself, still you would be getting the correct value of zeta. But from the second question onwards, definitely your approach would be wrong. So what I would suggest to each one of you, always have the proper reference of standard second order system. So one thing is quite clear, the numerator is not the omega n square alone, it also have the k. So always I would calculate the value of omega n from this factor, and if I compare omega n square is equals to 4, definitely the value of omega n became 2. Agreed? And the 4 was in place of 2 zeta omega n, whereas the value of omega n is already known to me. So 2 to the 4, the zeta became 1. And as the zeta is known to me, by default I can say it is gonna be a critically damped system. It's a critically damped system. Critically damped system. Yes. And if we'll talk about the nature of its pole, so that also we can easily configure. If it is critically damped system, obviously you can see the nature of poles are gonna be pure real, repeating at minus omega n. And similarly, if we'll talk about its output response, it would be pure exponent if it is excited by the step input. Similarly, the same process has to be used. Now, such a great effort I have taken to solve the first question, but now you would have a clear-cut idea where we can make mistake. So taking the reference of same concept, I would go to the next question. See what is happening over here. I would not watch over the numerator, I would just look over the denominator. Here the omega n square is equals to 4, the value of omega n becomes 2. So the value of omega n is 2. And here instead the 2 times of zeta into omega n, which is already known to be 2, is found to be 2. So the value of zeta is simply equals to 0.5. What does that mean of it? It's gonna be an underdamped system. Underdamped system. Agreed? Till this point nobody should have any doubt as such. Now if we talk about the third question, many of the students would do mistake on this problem. Keep in mind, one pole or either 2 pole goes towards the right hand side, the system becomes an unstable system, and you can see very well, if you want to check whether it's a stable system or unstable system, what you have to do, The denominator's polynomial has to get compared with 0. You would have a characteristic in your hand. Now from the characteristic equation, using the concept of Rautowitz, you can now deal whether it's a stable system or unstable system. So here it becomes s square s and thereafter s naught. So the component would be 1, thereafter it becomes 2, and thereafter it becomes -4, and again the -4 would come towards the component of s to the power of 0. How many number of sign changes they have? One sign change they have. That means one pole is towards the right hand side, pole at RHS. So it's a type of unstable system. And if we'll talk about its response, the response would be unbounded. Probably 2 or 3 times the problem have come into this pattern. The response would be unbounded. What does that mean by the unstable system? Unstable system is a system when it is excited by a bounded signal, the response used to be unbounded. Yes? Till this point, nobody should have any doubt as such. No. Last, never the least. Here, if you'll get the value of zeta, the zeta is definitely greater than 1, and here it's gonna be overdamped system. Overdamped system. Agreed? So nobody should have any doubt as such. If this part is clear to all of us, just write clear. So at least we can move ahead. Yes? End of the day, I can take even the last problem for the better clarity, and at least I would be able to cover the almost all sort of problem. So let me take the fifth question. And here the transfer function T of s is simply equals to of maybe 4 divided by of s square plus of 4. Which type of system it is? See, the location of or the component of 2 zeta omega and s is absent. What does it mean of it? The value of zeta is simply 0. It would be a case of undamped system. This would be the case of undamped system. So till this point, probably nobody would have any sort of doubt. So what I am going to do now, let me take few number of questions based on the concept which we have studied so far. Obviously, based on the concept of second order system. Here comes my first question. Yes. So anyhow, I am just giving the time frame of 20 seconds, and you guys had to reply which type of system it is. The problem states the solution of the differential equation d square x by of dt square plus of 2 dx by dt plus of 2x is equals to of 1 is critically damped, underdamped, overdamped, and steady. Tell me. And I know many of us would not be able to relate the problem with the concept of standard second order system. That is why this problem was taken as the first problem where most of us would get trapped. This is what my design problem is. So I want the perfect answer for this particular question. Tell me. See, many of us would be confused how 1 have come towards the right hand side. I know. Many of us would have a confusion over the 1 itself, and now they would understand, or now they would try to figure it out. So what to do with the 1 and how the system category would be classified. And I know many of us would be having the doubt over this problem. See, try to understand what's happening over here. See, whenever the differentiation takes place, usually the differentiation takes place for the output. You can see very well, at least in this problem, x, which is a function of t, is the output in time domain. Agreed what I am saying? And we have seen the right hand side of the differential equation used to be input to the system. Yes, no? Initially it used to be d square of c dt square plus 2 times of dc of dt plus 2 times of ct is equals to of rt. What does that mean of it? That means the input to the system, input to the system is 1. And if 1 is just being defined for the positive value of t, you can also write this as u of t. U of t. Could you understand what I am saying? That means it is a second order system which is getting excited by a unit step input. That is what I am saying. If instead the x and instead the u, if 1 is being written, definitely many of us would find this problem very difficult. What does that mean of it? It is still a second order system, whereas the system is being excited by a unit step input, and whatever the conclusion has been derived so far, no, the type of output is sustained oscillatory, overdamped, underdamped. In all of the cases, I have clearly communicated one thing: the input which has been used for exciting the standard second order system is the step input. It is the step input. So what's the problem over there? That means still it is a standard second order system which is getting excited with a unit step input. Agreed what I am saying? Probably I can feel most of the students would have the problem in this sort of the frame of problem. That is why I have taken this as a first problem. So tell me what we need to do. Just we had to figure it out, the value of zeta. How that will be done? First, I would be taking a Laplace towards the left as well as right hand side. Anyways, I am not worrying about the right hand side. I am just worrying about my characteristic equation. So the characteristic equation would become s square plus of 2 of s plus of 2, and I would compare with 0. And from this characteristic equation easily I would get the value of zeta, and from zeta easily I would get the value of the type of response the system would have. You can see very well. So the value of omega n is gonna be root over 2. So the 2 zeta omega n is equals to of 2. So the value of zeta becomes 2 divided by of 2 into 1.414, which is the worth of root 2. So you'll get to know the value of zeta is in between 0 to 1. So which type of system it is? It is gonna be an underdamped system. For the better understanding of the problem, they should have said the one when the t is greater than equals to of 0 or 0 elsewhere. But anyhow, it is well designed problem, and probably this is the problem where you guys can stuck yourself. So may I know till this point each and everything is clear? Probably this must be clear to all of us. Now let me go down to the next question. Yes. This problem have come in engineering services examination, year of 2001, in electrical paper. So let me read what the problem states. A second order control system is defined by the following differential equation. Again and again I have been taking the question which are based on the concept of the differential equation, because so far whatever the type of studies we have made, we have made over the S domain, and sometimes it becomes very difficult to correlate how the question would look like in the time domain if we have been keep analyzing the system into the Laplace domain. That is why again and again I am taking few of the problems which are connecting the problem into the time domain. Again the same thing goes. You can see what is the input which is being applied to the system. You can see very well. Whereas the 4 is a common factor, you can take that 4 common. So end of the day what will happen? This would become 1, this would become 2, this would become 4, this would become 4, and this would become 4. So virtually again we have been dealing with a standard second order system. Now the input which is being exciting this system is nothing but the 4 times of ut. Keep in mind, whether you are applying 4 times of ut, whether 16 times of ut, if the input is a ut, by default, if it is an underdamped system, it would oscillate and thereafter it will reach to its steady state value. Similarly, if it is overdamped system, by default, it would be a pure exponent. Keep in mind, if the nature of the input is still a unit step input with taking any sort of magnitude, the nature of the system would not change, but yes, its steady state value would change. So may I know each and everything is perfect or not? So yeah, I wanted to ask one thing. I am watching over this live. The videos are getting buffered. So I just wanted to know from you guys, each and everything is perfect or not? Or I can say the probably we would start from this same topic from tomorrow onwards. Yes, we'll meet tomorrow with the same topic. Thank you very much. So again, probably each and everything is perfect. I wanted to ask from each one of you, still it is buffering or not? Still it is buffering or not? Because I would like to end my session today itself, because we cannot keep on carry the same and same theory again and again. I wanted to ask from each one of you, may I know still the problem is persisting, or now it is everything is fine? Now everything is fine. Tell me. Tell me everything is fine or not, because now we are going to keep my class ahead. All good, sir. All good. All good. More number of inputs I want. Each and everything is fine or not? Each and everything is fine or not? Fine, sir. Okay, okay, okay. So we'll go ahead with today's video, and still if the problem takes place in future, I would be interrupting my video there itself, and probably the remaining part we would be watching in the next video. Yes, sir. So anyways, come back to this point. See, again the same concept has to be used. See what is happening over here. Once you'll take a Laplace over the left hand side, it would become s square. Here it would become 2 times of s, and here it would become 4, which would be equals to 0. Yes. So what I would do, first I would calculate the value of omega n, easily taking the square root of 4, obviously it would become 2. And here instead the 2 zeta omega n, the value is 2, where the value of omega n is already known to be 2. So the value of zeta is equals to 1 upon 2. So I wanted to calculate the value of zeta as well as omega n. You can see very well the value of omega n. What used to be the unit of it? It's gonna be radian per second. And what's the worth of zeta? Zeta is nothing but half. And what used to be the unit of it? It's gonna be unitless quantity. So what's gonna be the bestmost answer? Bestmost answer is gonna be B. So nobody should have any doubt as such, at least on this problem. So let me do one thing. Let me go ahead with the next question. Yes. Although I cannot show all of the responses which are there within this PDF, but at least by watching this problem or watching the complete sentence which has been allocated with this problem, you would be able to draw how would be the response of this given system. This problem have appeared in GATE Electronics year of 2003. The problem was framed by IIT Madras. Tell me. See what the problem states. A second order system has the transfer function Cs divided by f Rs is equals to a 4 divided by f s square plus 4s plus 4 with R of t as the unit step function. The response of this system is represented by the 4 number of different options were given. So let me do one thing. Let me show all of the 4 options. This was the first option, this was the second option, this was the third option, and this was the fourth option. So let me see the problem once again, and we'll try to decode this problem out. Tell me, how would be the response of this system? Tell me, what would be the bestmost answer? Just try to understand how to figure out or how to crack this sort of problem. See, just focus over the value of zeta. Try to understand what I am saying. Just focus over the value of zeta. How we would get the value of zeta? See, the omega n square is 4. That means the value of omega n is equals to of 2. And instead the 2 zeta omega ns, the worth is 4. What does it mean of it? Instead the 2 zeta omega n, where the omega n is still 2, is equals to a 4. The value of zeta is found to be 2. Yes. So what does it mean of it? Sorry, it has been found to be 1. So which type of system it is? The system is gonna be critically damped system. critically dense system. That means it would be pure exponent. Pure exponent. It would be pure exponent. That's fine. That's no doubt as such. But you should also know its initial as well as final value, because as far as this problem is concerned, although the final value is already been set to 1, but still there could be a different possibilities in your options. The few of the options might be getting settled at 1, few of the options might be getting settled at 2. So you should have a clear-cut idea for this system what would be its steady state value. What would be its steady state value? May I know how to deal with that? We have already talked about that in the great detail when I was discussing about the concept of steady state response. For the second order system, you can see very well the response at t is equals to of 0 for a standard second order system when it is excited with the step input is simply 0. That means the response would start from 0. You can see very well, either you take first option, second, third and fourth, they all are probably starting from 0. Now if we talk about the steady state response where the limit t tends to infinity, c of t. What was the worth? We have already calculated. The worth is gonna be k into k dash. K into k dash. What was the k dash? The k dash was the magnitude of the step input, and similarly the k was the DC gain inherited by the transfer function. May I know what's the worth of the DC gain? See, this used to be k times of omega n square. Omega n square is already 4. That means the value of k is simply 1. The value of k is simply 1. Yes. And may I know the step input which has been applied to the system, what is the magnitude of it? It's a unit in the nature. By default, this would also be 1. This would also be 1. That means at steady state, it would get settled at 1. Otherwise, you can use the concept of final value theorem. In final value theorem, what you would do? You would multiply this with 1 upon s. Why? Because this system is getting excited with a unit step input. The ut would have a Laplace equivalent as 1 upon s. That would become a response in Laplace domain, and now you will apply a final value theorem. There also you would get the response as 1. You would get response as 1. Agreed? Nobody should have any doubt as such, at least on this problem. Nobody should have any doubt as such on this problem. Agreed till this point? Yes. So you can see very well the response would be at t is equals to 0, the response would start from 0, and at steady state it would fix to 1. It would fix to 1. And being an exponent signal, it would never be crossing 1. See, if it is an underdamped system would have an oscillation. That means it would be oscillating, it would be damped, and thereafter at steady state it would get settled at 1. Agreed? But this is not case. This is not the case, and it would be a pure exponent. What does it mean by the pure exponent? See. Could you figure it out or not? Its slope would be continuously decreasing. Here the slope was higher. Here the slope is lesser. Here the slope is more lesser, and here the slope is even lesser. That is why it's a pure exponent in nature. Pure exponent in nature. So you can say that would be your bestmost answer. That would be your bestmost answer. So tell me, what's gonna be the bestmost answer? Obviously, A can't be the best answer. Why? Because you can see over this problem, there was a overshoot. What does it mean by the overshoot? That means the response from the system got above the value of steady state value. That would happen only and only when the zeta is in between 0 to 1, neither 0 nor 1. Even there used to be the ambiguities between B as well as C, B as well as D. B as well as D. Yes. So the bestmost answer is gonna be B. Bestmost answer is gonna be B. B. C can't be the answer. May I know when you will be having C as the answer? The C is nothing but the sustained oscillatory response. That's possible only when the zeta was 0. There was certain mistake in option C. So you keep aside option C for the time being. You keep aside option C for the time being. Yes. You just focus over this. You just focus over this. Agreed? So nobody should have any doubt as such. So let me go ahead with the next question. Deliberately I have taken this problem. See, match list 1 and 2. Select the correct answer using the code given below the list. Yes. Anyways, what I would do? I would post this PDF over the Telegram group such that you can solve this problem by yourself, because this problem does not have good amount of concept. You can solve by yourself. You can solve by yourself. Now let me take a few of the self-designed problem, and you guys have to reply what would be the best most answer for the given problem. Best most answer for the given problem. Just take the problem like this. The problem is sort of, let me take few number of problems. Sir, which type of problem it could be? Like the denominator, instead the omega n square, I have taken the value as 4. Now here we have taken the worth as a of s plus of, or rather do one thing now. Chalo, okay, no issue. And you can take this as 4 times of k. 4 times of k. Yes. The input goes to this system. Input goes to this system. Input goes to this system. And let's take the input to this system is k dash times of ut. K dash times of ut. I need to draw the output response in time domain. This sort of problem, if you are able to deal, probably you would be able to smash almost all sort of problem related to the time response analysis. No, that we are going to come, no issue. Itira, probably we are going to come at that point also. Yes. Now we have taken a situation. Try to understand in this way. At very beginning, the first scenario is like the value of k is equals to of maybe 1 by 2. What does that mean of it? That means the numerator was 2, whereas the denominator was s square plus as plus 4. Agreed? And now I have taken a scenario. We have got a step input with the magnitude of 2. Deliberately I am changing the things again and again such that you would have a clear-cut idea. Till this point nobody should have any doubt as such. Yes. And now I am taking the value of a is equals to maybe somewhere 2. May I know what would be the response, or how would be the response of the system? You can draw very well over this plane. So let me do one thing. Let me take the response axis. Let me take the time axis. Yes. Response axis and time axis. So first tell me what would be the value of zeta? You can see very well the value of omega n is nothing but 2, and instead the a has been clearly given as 2. So you can see very well 2 zeta omega n. Instead the 2 zeta omega n, we have got a, where the a has been selected at least for the first problem as 2. Yes. The 2 and 2 goes off. Even the value of zeta can be easily calculated by taking 1 divided by of omega n, which is equals to of 2. That means the value of zeta would remain 0.5. Yes. Not only that, even you can figure out what's gonna be the steady state worth of the response, which is equals to of k into k dash, which is nothing but half into 2, which is equals to of 1. That means still your response would start from 0. Being an underdamped system, it would be oscillating, and thereafter after certain amount of time it would get settled down to its steady state response. May I know what it is? It is nothing but 1. Yes, it is nothing but 1. Agreed? This is the response when the value of zeta was 0.5. Agreed? Till this point nobody should have any doubt as such, which I feel. Now let me take the next question. So what I am going to do over here, let's take k dash is 1 and even k is also 1. But here the a has been made 4. Agreed? So you can see very well. Again, first I would be calculating the value of zeta. May I know what would be the zeta over here? Still the value of omega n square is in place of 4, that means the value of omega n is 2 and the value of a has been chosen as 4. So how you will get that? 2 times of zeta into omega n, where the omega n is already 2, which is equals to a 4. From here you would get the value of zeta, which would be equals to a 4 divided by 4. The result is simply 1. The result is simply 1. Agreed? May I know which type of system it is? It is a critically damped system, and hence the response is gonna be pure exponent. Pure exponent. But still it would get settled down at k into k dash. K into k dash, which is still 1. Which is still 1. Agreed? That means the response when the zeta is 1 would be sort of, it would be pure exponent. Yes, it would try to get settled down to the same value. Agreed? Let me take the third question. Let me take the third question. Third question. And here comes the major change. Here comes the major change. See what it is. What I am going to do over here is still the k has been chosen. K has been chosen maybe 1, and even the k dash has been chosen 1. But here the a has been chosen to be, let's take somewhere -3. -3. Yes. -3. Deliberately I have chosen a is equals to of -3. Keep in mind, now it would not get settled to any steady state value. It would be an unbounded signal. Why? Because a is -3, that means the zeta would become negative. If the zeta would become negative, by default the system becomes an unstable system. So let me calculate the value of zeta. See, if I calculate the value of zeta, first I would focus over the value of omega n, which is 2, and instead the 2 zeta omega n, we have got a is nothing but -3. Yes, where the value of omega n is also 2. So you got to know the value of zeta is equals to of -3/4. Yes. Anyways, let me tell you what would be the response of the system. Although they are not going to ask this sort of questions, but still I feel they may frame this sort of problem. See, try to understand in this way. So far I was discussing over the left hand side of the S-plane, but this problem is towards the right hand side of the S-plane. Yes. You can see very well in between this to this part, the zeta was in between 0 to 1. Here it was precisely 0, here it was precisely 1. But here towards the right hand side, the complex conjugate pole would have the values in between 0 to -1. When the zeta becomes precisely -1, both of the pole would get repeated at omega n, which would be purely real. But anyways, if the pole goes towards right hand side, the output would be unbounded. But still you guys should have a clear cut idea. There could be two different ways through which the output can get unbounded. Either after oscillating, it is keep increasing its magnitude and becoming unbounded, or there could be the next method, it is pure exponent and thereafter it's getting unbounded. So you can see very well in between this region, because the pole also have the imaginary part, and because of the imaginary part, as I have communicated earlier, there would be oscillation, but here the magnitude of oscillation would be keep increasing. From where to where? When the value of zeta is in between 0 to -1, and as the value zeta becomes -1 or lesser than -1, what will happen? Now the pole would be either at this point repeatedly or towards this side or this side, and here the response would be increasing exponent. Agreed? Anyways, I am not going into the great detail, at least on those part, but still you can correlate with the quadratic outcome which we have calculated once I was dealing with the standard characteristic equation of the second order system. So here, may I know what's the zeta over here? The zeta is in between 0 to -1. That means what would be the nature of the pole? The nature of the pole would be complex conjugate having positive real part. Because of imaginary component, it would have oscillation, and because of positive real part, it would be keep increasing. That means the response would be somewhere. Exactly, I am not drawing. The response would be somewhere sort of this. Agreed? Here it would become zeta is equals to of -3/4. Let me take the fourth question. What it is? Let me take the fourth question. What it is, what I am going to do over here, A has been taken as minus 3. Let's take the A is equals to of minus 4. A is equals to minus 4. So what will happen? Here you would be getting the value of zeta is equals to of minus 1. And as at zeta is equals to plus 1, the roots were pure real, repetitive and having the real part as negative, but now it would be pure real, repetitive and having the real part as positive. What will happen? It would be pure exponent, but now it would be increasing. Now it would be increasing. What does it mean of it? What does it mean of it? It would be the response. It would be the response. See, what a vague output we could draw out of this problem. So here the zeta is equals to of minus 1, and even if you will take zeta is equals to minus 2, it would be a pure exponent, but it would be unbounded. It would be unbounded. So may I know till this point each and everything is clear or not? Till this point each and everything is clear or not? Till this point each and everything is clear or not? If it is clear, just write clear over the live chat, so at least I'll get to know the things are properly communicated. And I have seen only once this problem have come where the output is unbounded, and even they have given the two different options. In first option the output was unbounded exponentially, and in second option the output was unbounded oscillatory. No, who said the steady state value is always 1? Who said? You just do one thing, keep the value of k is equals to of 2 and keep the value of k dash is equals to of 3. You will multiply them together, the steady state value would become 6. Steady state value would become 6. Agreed? Nobody should have any doubt as such. And from where the steady state value have come, you had to do one thing. See, k dash, the Laplace of ut is nothing but the 1 upon s, and similarly the k would remain constant. You just multiply them together, you get the response in the Laplace domain, and then apply the final value theorem. You will get to know the steady state worth is simply gonna be k dash into of k. If you want, I can show you how. See. Divided by of s, and in steady state you would be multiplying with the s, and that s would go off, and the component which would be left out is simply gonna be, see, k dash into k into 4 divided by of s square plus as plus of 4. And at last you have to feed limit s tends to 0 once we apply the final value theorem. Obviously we had to feed limit s tends to 0, and once we will feed limit s tends to 0, this would become 0, this would become 0. Only the factor which would be left out is going to be k into k dash into 4 divided by 4. 4 and 4 goes out, so definitely the steady state worth is going to be k into k dash. K into k dash. Yes, nobody should have doubt as such till this point. Agreed? Any doubt if you guys are having still can ask over the live chat. Otherwise, I would be binding the concept of time response analysis of the second order system here itself. Promit Roy, I can't say about it because from here onwards the important chapter starts, where I would be discussing about the root locus, and even I have seen many of the students find themselves very difficult once they are dealing with the concept of the Nyquist plot. So definitely there we are going to spend more amount of time. So exactly or precisely I can't say. But my agenda was to take around 30 to 35 hours for the control system, so you can calculate accordingly. Each day around 90 minutes I am going to spend over the control system, and probably 10 or 11 number of classes are already over. Solving PYQB enough for control system? I couldn't understand what I am saying. I couldn't understand what you are saying, so please elaborate what you wanted to ask from me. Anyways, probably each one of you are not having any sort of doubt, so I would end my session here itself, and we would start from the new topic from tomorrow onwards. Till then, bye bye, take care, thank you very much.